Hello again. Welcome to lesson 41, the statics lab, as I'll call it. This is going to be broken up into two parts, so pay very close attention to what I'm telling you here. This is going to be two parts. Day one is today. This is where I'm going to kind of get you started, right? You're going to follow my lead. I'm going to give you some of the setup to how to do these problems and try them. And then you're going to try your best on them with the knowledge that we've gotten from the past two lessons. You're going to try and apply it and what I would call guesstimate. You're going to take a guess and see if you understand. And if you don't get it right, it's not a big deal. That's why I said when you do your sections, use a pencil. If you want to write the parts that I write in a pen, that's fine. And then when I tell you to do the rest, do that in pencil in case you need to fix it tomorrow. And then you're going to submit it today. So when you do your best today, I will start you off and you will finish it. You're going to take a picture of that. Even if it's the wrong answers, you take a picture because it's worth marks. I will not take any marks off for trying. You are allowed one time in this assignment to say, I don't know as an answer. I'll give you one, and otherwise you got to guess. Try your best, but you can put one I don't know and try not to even use it. Try and say, well, I know this and I know that, so it's kind of draw. And this is all about drawings too. You're going to do little drawings. So today you're going to follow my lead. I'm going to start you off. I'm going to give you some of the answers and set up the questions. And then you're going to try and fill them out in pencil. And then you're going to submit pics of that today. Day two will be tomorrow, and I'll have a separate video for that. And what that's going to be is we're going to go over it. I'm going to give you the right answers, and I'm going to actually conduct the experiments in the diagrams in the real world so that you can actually see them happening. And I'll explain what's happening, and I'll give you the correct answers. And you're going to have to get the updated answers from me, fix up all your answers, clean them up, and submit another picture for day two. So there'll be two parts. I'll say part one. I can almost say part one and part two for lesson 41, part one and part two. So today, follow my lead, try your best, do the entire sheet as best as you can, and submit a picture. Tomorrow, I'm going to give you the answers and show you all the experiments, and you're going to fix all the mistakes you made today, clean up your sheet, and submit a new picture. So today you submit a picture of your best tries. Tomorrow you submit a picture of everything cleaned up. That's what we're doing. So let's get at it. The sheet you're looking at today, let's look at the Mac here. The sheet you're looking at is I don't want to do this. Look at this. This is the sheet we're doing. We're doing electrostatics lab, and let's go right to the procedure here. So I'm going to actually not use the computer for this because I'm going to do some stuff on the document cam. So here we are. Make sure you get to this page. I'm going to try and draw it nice and clear. So I'm going to do the first couple for you, and then you're on your own. So perform the following steps and use diagrams, and this is the key. You've got to use diagrams. This is how we show what we know in electricity. It's always a diagram. It's always showing where negatives are jumping, where positives are moving. It's always diagrams. Everything is diagram based. You have to be able to draw it to prove it. You can't just say this, that, and take guesses. You need to actually draw things. So this is a diagram heavy assignment. So touch a suspended pith ball with a charged positive rod. Touch it to the pith ball. So what they're saying is, in theory, take a positive rod and touch it to the pith ball. What's going to happen? I won't show you today, but I'll draw it for you. Positive rod touches the pith ball. What would happen? Let's draw from an electrostatic perspective. Let's draw that. All right. So I'm going to draw a pith ball. The pith ball is neutral, so it's got pluses and minuses everywhere, right? It's a neutral. I could say neutral pith ball. And I have a positive rod coming near. And this rod is very positive all around it, right? what's going to happen? What's the rule with neutral? Do neutrals attract to things? Yes, neutrals attract to charged objects. So we have to start to say attracted. All right? Because what's happening here, to be more precise, is that the negatives on one side of the pith ball move, and the positives are scared, so they move to the other side of that pith ball. And at the same time, this rod is very positive, so these negatives are attracted to the rod, and this side is scared of it. Okay, these negatives are very attractive, but as soon as it touches, what's going to happen? So this is step B. Pause it as you need. The rod touches the pith ball. What happens when the rod touches the pith ball? Okay, so the moment they touch, I'm going to tell you that the second they touch, all of the negatives jump to the rod. Negatives in pith ball jump to rod because opposites attract. Now think about this. There's a problem now, because what charges the pith ball? It just lost a bunch of negatives. So the pith ball has become very positive. And the rod, even though it absorbed some negatives from the pith ball, is still overwhelmingly positive. So now you've got a positive rod and a positive pith ball. They're going to be repelling from each other. They're going to have repulsion. Let's just see if it's true. Positive rod, pith ball. Neutral pith ball, I'll ground it using me. Okay, so it's going to, let's see, well, you'll see it here. Take a look. Watch. It's attracted, and as soon as it attracts, it's going to jump away. And now it is scared. I can't even touch it. I'm bringing this rod, and it's afraid of it because this is positive, and that has become positive because it lost electrons. Cool. All right. I think that should have, sorry, I got this stuck to me now. I think the wheels are turning, right? So let's move on to the next part. What happens after when the ball and the rod repel? Well, what you could say is the pith ball swings away because now the pith ball is almost mostly positive and the rod is mostly positive. And they repel because same charges repel. R-E-P-E-L. There you go. What charge does the pith ball have, and how do you know? That one you can try and explain on your own for now. How do you know that the pith ball is positive? Let's see. So that one you can try on your own. Okay. Repeat steps 1 and 2 using a negative rod. So now it's going to be slightly different, but look at, I'm going to give you proof of it. The same thing is going to happen, but the movement of electrons is different. So can you figure this out? Look at it. The same thing is going to happen. I'm going to prove it to you. I've got this pith ball, and I've just made a negative rod, and they're going to attract and repel, right? Attract and repel. But the electron movement is different in this one. So I'm going to let you try this one, but I'm going to set it up for you, okay? So we've got a negative rod and a neutral pith ball. So let's see down here. This is where you can try this on your own. So you will have, you're going to have to draw 3 drawings for this. Near, what happens when the rod is near, what happens when the rod touches, and right immediately after. Okay, and you know there's going to be attraction, transfer of electrons, repulsion somehow. So I'm going to start with the first drawing. you're going to have a negative, and negative rods generally have pointy tips. So we've got a negative rod and a neutral pith ball. And in that neutral pith ball, the negatives are going to go to this side, and the positives are going to go to this side, and they are going to attract. Now when, and you can draw the electrons on this one, when they touch, what happens, and why after do they repel? Draw those electrons, draw the electrons. What happens here in your guess? What happens here in your guess? And this, number 4, is almost like a philosophy question. If we know that neutrals do nothing, and neutrals will attract, and opposites will attract, but same charges will repel, how do we for sure know the charge is something? What's a test we can do? What is the most true way? Because if something's neutral, I don't know. I can bring a charge and it'll stick to it. And if something's positive and I bring a negative, it'll stick. And if something's negative and I bring a positive, it'll stick. The only true way to know is if it's afraid. So I'm going to let you, if it's repulsion, so I'm going to let you try this one on your own. But this is a tricky question. It's more philosophical, but in theory, what is the only way you can really test what a charge is? Because neutral's the thing that makes it messy, right? Because neutral will kind of do whatever. So this one you can try on your own. How can you definitively test an unknown object for charge? So I tell you, I got this object that's charged. Prove to me what the charge is. I got a pith ball. Can you prove if it's charged? Tell me what kind of charge. What's the test for it? That's a tricky question, but I'm going to let you try it for today. So far you have to do this, fill that out, and I've done the rest that you need to copy and draw. Pause the video at any time. Now I'm going to move over to number 5 here. All right. See, now we're getting into a little bit more elaborate setups where you're going to have glasses, because this glass is a terrible conductor. So if I hold it, the electricity is not going to go through the glass. So it's almost like you've got 2 pipes floating in space. And you're going to do things where you touch the pipes and charge them and then separate them. Or you're going to do things, sorry, I'm just going to fall. You're going to do things where you charge it and remove it. Or you bring a charge to one side and a pith ball on the other and see what happens and things like that. So that's kind of what we're looking at in the next set of questions. It's like the first things we just did right now, those first questions are the easiest ones. This is like middle plus difficulty, and then there's one more type of question that's the hardest type of question. It's an induction type of question. But for now, let's just look at these questions and see what we can do. Right. So bring a positively charged rod close to one end of a copper pipe on a glass beaker. Touch the other end of the pipe briefly with your finger. Now listen, you're going to try this on your own, but your finger in this is the ground. It's the neutralizer. All right, so let's do this. So we're going to say bring a positive rod near one end of a copper pipe. So I'll have a copper pipe here sitting on a beaker, a nice piece of glass, right? Touch 2 drawings, and then when you have this positive rod, so you need to draw in this diagram where the electrons in this neutral copper pipe are. I'm going to give you a hint. The positives are scared, so they're probably over there, and the negatives are probably here, right? So this is that positive rod, but now you have your beaker and you have your pipe, but you have touched it with your finger and then you removed it. What happened here? What do you think happened? Negatives are repelled. What do you think just happened? What did the electrons do? Draw that. So draw what happens to the electrons here and test it for charge. Well, we can't do that, so you obviously can't test it. But say, what charge is pipe after? Tell me what your guess is there, okay? Number 6. So you can see this is a little more tricky now, but we're going to do these tomorrow. Today I want you to think about them, draw them, show where the electrons are moving. You had a hard day yesterday, so I'm kind of breaking this one up into 2. All right, so place a metal pipe on a glass beaker. Okay. Suspend a pith ball so that it touches the end of the pipe. Touch the other end of the pipe with a rod. Okay. So, and then repeat it with a wood dowel. So this will be the wood repeat. And this will be metal pipe on a glass beaker. I'm going to draw it a little smaller. A metal pipe on a beaker. And on one end, you have a pith ball. Pith ball is neutral. Touch the other pipe with a charged rod. Let's use negative, okay? Let's say that we bring a negative rod and we touch it. What are the electrons in here like before? You know that this is going to be neutral, so you're going to have to draw some positives and negatives, and this metal rod is going to be positive and negative, but this rod will be negative, and there's nothing happening here. After touching, you're going to need to draw what happens. And I'm going to give you a clue. You got this metal rod here. It's become charged, and your pith ball is also going to be floating away. There's going to be repulsion. So what does that mean happened? What do you think just happened? And with the wood, if you brought metal, or if you brought a charged rod and you touch it to a piece of wood, what happens in your mind and why? And this is a tough question, right? I'm going to give you a hint. Not a lot's going to happen, but can you tell me why? So that's what you got to figure out on that one. And I've given you some help there to set you up, and you got to explain where the electrons are moving. So you got to draw electrons and protons in here, and electrons and protons in here, explaining what happened. And then the last one. And I know some of these are like a little bit weird, but what do you think the electrons would be doing? That's what I want you to think about today. And don't worry, tomorrow I will fill the rest in and explain it and do experiments to prove it. So let's take a look at the last thing you need to do. Well, second last thing. Place 2 copper pipes in glass beakers so their ends are touching. Okay, so we've got a glass beaker here and a glass beaker here. And we've got 2 copper pipes so that their ends are touching. Sorry, I screwed that up a little. They're touching. The pipes are touching. Okay? Bring a charged rod nearby. So show me what happens if I bring a negative rod nearby. Draw where the electrons go, or where do protons and electrons go. Draw that in here, in these 2 metal pipes. Since I've brought this negative, what's going to happen? And since they're touching, they act as one pipe. So what are the positives going to do? What are the negatives going to do? And then when you separate, once you bring it close, you don't touch, and then you just go, and you split them apart quickly, and you remove the rod. What charge will each pipe have? And you can draw that out and explain it. And the last thing to do is just a repeat of what you've done. But if molecule A and C were beside each other, what would they do? And what I'm looking for is if A is negative, because it tells you A is negative and C is negative, they would repel because they're the same. B and E, so positive and a neutral. What do you think would happen if a positive and a neutral did? Would they attract? Would they repel? Would they do nothing? Your choice. Fill these ones out again. Do that. So that's your assignment today. Your assignment today is write down the starts that I gave and try and finish the diagrams by showing the electrons and the protons and where they've moved and what they've done, answering any questions that are in it, and doing that last sheet as a review kind of like charges attracting and or opposites attracting and like repelling and how neutral behave. So your job is to follow the stuff that I just did. Try your best on the questions I've asked of you and fill it all out and submit a pic today. Submit what you tried, even if you're wrong. Tomorrow, I'm going to go through it with you, and we're going to clean it up, and you're going to get the right answers. But today, I want to see what you tried, and it's okay to make mistakes today because this is a brand new concept showing the drawings of electrons moving. So use a pencil, because tomorrow, we're going to clean it all up, and I'm going to show you, right, these kinds of experiments when I have beakers with metal rods, and they touch and they move apart and things like that, right? So we'll do that tomorrow, but this is what you're on. So for today, please take pictures of this, this, and that the best you can. And tomorrow we'll go through it together, and I'll give you some of the answers, and we'll explain it. And I'll even demonstrate it for you. So hope you're doing well. We'll see you soon. Take care.